Okay, I tried to squash 3 pages into one. Okay, so it goes question 1, question 1, question 2, 3, 4, and then 5 and 6 here, so that you can see the original table and compare the answers. I don't think there's much to explain in questions 1 and 2. Pay attention to the word closest for question 2, because if you do the calculations properly, the answer you'll get is 1938, which is not one of the options from A to E. The closest one requires you to round 1938 to 1900. Then you get D as your answer. Okay? Now, questions 3 to question 6 is based on this table. It's testing your vocabulary, your understanding of what the words mean. So, question 3. The mean and standard deviation of the variable distance. All you have to do is to put these values into your calculator and then ask it for the information. Yeah, did the analysis part, and you should get the correct answer out. Now, question 4. The number of discrete numerical variables. Discrete, no decimals. I mean, you can have decimals in others, in some situations, but in the situation of number of children, you only allow whole numbers. We don't count the 6 months pregnant type stuff. Okay, so number of children, 1 or 2 or 3 or 4 or 0. Postcode is just a number that people give to help post office sort letters more effectively, so that it can get our letters to us in a timely manner. Type of cars, again, it's just the 1, 2, 3 is just for convenience in programming. 1 represents sedan, 2 represent wagon, and so on. So in reality, even though these are numbers, it is a categorical data. Number of children is definitely numerical and discrete. Female and male, obviously categorical, and distance is numerical, but it is not discrete, because distance can be broken down to smaller and smaller parts. Question 5. The number of ordinal variables. Ordinal is a type of categorical data which is ordered. There are no ordered things. So by ordinal, an example of ordinal is, what's your opinion of Kubo and the Two Strings, the movie? So then you say, oh, I love it, number 5, to I super don't like it, number 0. It is ordered. You can go from 0 to 5 or 5 to 0 to represent how much you like it or don't like something. Okay? None of the categorical data in this table are ordinal. Finally, question 6. The number of female drivers with 3 children in the car. This is an easy question. You can figure it out yourself using the table. Question 7 is a transformation question. Look at the scale factor. Okay? Even in the practice exam, you notice that there are quite a number of questions which relies on your paying attention to the graph labels. Okay, so in this particular case, the x-axis is done in log base 10 format. Okay, so when the question asks you the percentage of countries with an annual per capita oil consumption of more than 10 tons, first you have to convert it. So more than 10 tons, this 10 goes here. Okay, so log 10 of 10 is equals to 1, which means that what they are looking for is the percentage of countries with an annual per capita oil consumption of more than 1. Okay, so that's why looking back at the graph, this is 1, so this is the only bit which is more than 1. Between 1 to 1.5, there's only 1 out of the 58 countries. 1 out of the 58 countries. You do the calculation and then round it properly, you'll get the same answer as me. Question 9. See if you can follow my explanation. I'm not going to spend too long on it. Question 10. See how I've put a question mark and star next to it? Because I have to read it like 10 times before I kind of guess what it's trying to tell us. Okay, this question is worded in a way that I'm not familiar with. It's just not how our textbooks have worded it. So basically, what it's asking for is how can we best use a back-to-back stem and leaf plot. But a single back-to-back stem plot would be an appropriate graphical tool to investigate association between a car's speed and something. Took me a while to figure it out, but basically it's saying that, okay, we want the data inside the back-to-back stem leaf plot is the speed, okay? So we can use it to compare two things. So, for example, we've used back-to-back stem and leaf plot to maybe compare results for two classes within Elkira, or we can use it to represent or compare results between Elkira and Cambria, and so on and so forth. The two sides of the stem leaf plot must be easy or consistent, something that we can compare. So the answer for A, driver's age in years, would be kind of like how, okay, that's my question. How can we compare the driver's age in years on one back-to-back stem and leaf plot? Car's color, white, red, gray, other, that's more than two things. Car's fuel consumption, again, a similar question as to A. How do we separate it into back-to-back? Average distance traveled, same question. But driver sex, you've got female and you've got male. You can have one side female, the other side male. So I guess the answer, and I checked my answer and my answer is correct, so that must be how it's explained. Okay, question 11 is asking you for the slope, so the gradient, and we know the formula for calculating gradient is either rise over run or y2 minus y1 over x2 minus x1. Okay, so the important thing about question 11 is you need to identify which is your explanatory variable, which is the x, and which is your response variable, the y. Okay, so I've labeled weight as the x and fuel consumption as y. Then all you have to do is to set out the information given to you into sets of coordinates and then substitute it into the formula, like what I've done here. Now, question 12. Have a read of the questions, pay attention to the things that are underlined, and compare answers A, B, C, and D, and think about why D is the best answer out of the lot, because A, B, C pretty much talks about similar things, but slightly different, okay? There's only one correct answer. You cannot put in all four as your possible answers. Question 13. It's the formula is pretty standard, but it's trying to confuse you with the numbers, okay? So we started off with 1.25. If you look at it, I've substituted it into the correct formulas, but 1 divided by 1.25, 1 divided by 1.25, well, what I meant is like actual divided by 1.25 is the same as actual times 1 over 1.25, okay? So 1 over 1.25 is the same as 0.8. Now, 1 minus 0.8 is equals to 0.2. That's why the answer is reduced by 20%. It's not increased by 25%. You need to use this formula. You need to make sure that you go 1 over 1.25, which gives you 0.8, but then 0.8 does just tells you that it started from 100%, it's now 80%. So the reduction is 20%. Okay, so you have to do the last bit to get the correct answer. Question 14, the seasonal index for December. Now, seasonal indexes, remember we talk about it. If it's split in, the year is split into 12 months, then your seasonal indexes, when you add it all up, it must equals to 12. That's why to figure out the one for December, I just add up from January to November, and then take away that value from 12, and I'll give you the correct answer for December. Okay? Now remember, if the year is split into quarters, spring, summer, autumn, and winter, then your seasonal index will add up to 4. Okay? Question 15. In May, the store sold blah blah blah, the deseasonalized value. It's just substitution into the formula. Deseasonalized equals to actual divided by seasonal, which is the same formula we have used before in question 13, but a different way. We used it in a different way. This question is asking you to do 5 median smoothing. Okay? Now, 5 median smoothing, the middle number of 5 numbers is 3. Okay? Which means that we'll lose the first 2 data points. If you start with January and February, when you do 5 median smoothing, you'll lose January, February. And at the end of it, you'll also lose November and December. So if you just use that information alone, you'll see that A is not correct answer because it's got a February information, it's got a November information. C is definitely out as well, too many data points. E has too many data points at the end. So the only 2 possible answers are B and D. And D is incorrect because the median, when you look at April, when you look at the April data point, you have to look from February all the way 1, 2, 3, 4, 5 to June. Okay? If you look at the 5 data points, the middle number, so you start from the top going down, the middle number is this value here. Okay? Which is why it should be on the line where the 6 is. This is a correct data point. This is an incorrect data point. So the answer is